Because what do we do when we have an exponent of 0? Well, like you might have noticed with the previous example, when we have something and we're dividing it by itself, well, if we have it all expanded and we go to eliminate, well, we eliminate everything. So when we divide something by itself, it equals 1. Therefore, anything raised to the 0 power always equals 1. So this z to the 0 back here also equals 1. It eliminates. So our final answer is 6/7 y squared. So let's do a few more 0 exponents. These are nice and quick. We just need to pay attention to what the base is. Here we have 7 raised to the 0 power, which is just 7. Which is just 1. Here we have -7 to the 0 power. Only the 7 is being raised to the 0 power. The negative is not. So we take the 1 and then make it negative. This time it's in parentheses. So the whole thing is being raised to the 0 power. Therefore it is just 1. Doesn't matter how complicated the expression is inside the parentheses. Since the whole thing's being raised to the power of 0, it equals 1. But now the 2 is on the outside. So we raised the inner expression to the power of 0, which equals 1, and then we can go ahead and multiply. Here, only the x gets the exponent as well as the y, so we have 2 times 1 plus 1, which equals 3. When we eliminate, we are left with 1 over x times x, 1 over x squared. Well, let's extend this to our quotient rule. Quotient rule says we can go ahead and subtract. So x to the third minus 5 equals x to the -2. So when we cancel it out, we get an x squared in the denominator, but when we do the subtraction, we get x squared. That's because a negative exponent is equal to its reciprocal. And we see that with our rule here. X to the -n equals 1 over x to the n. We can make the exponent positive by writing it in the denominator. So let's simplify and write with positive exponents only. This allows us to actually evaluate when we can based on the numbers that we're given. So our base is 5, so we have 1 over 5 squared. We can go ahead and square 5 and get 25. Here we have 1 over -4 to the 4th power. For -4 to the 4th power is 256. Here we have 2 times 1 over x to the 3rd, leaving us with 2 over x to the 3rd. Now the entire base is 3x, so that will be in the denominator, and it's raised to the 1st power, so we don't need to do anything else. Here we can go ahead and apply our quotient rule, which is m to the 5 minus 15, gives us m to the -10. Then we can use our negative exponent rule and rewrite it as 1 over m to the 10th. Here we have same idea, 3 to the 3 minus 6, which gives us 3 to the 3rd, -3rd, and then we can rewrite that as 1 over 3 to the 3rd, 1 over 27. 2 to the -1 is 1/2. 3 to the -2 is 1 over 3 squared. And we can add those together. We get 11 over 18. Now let's think about our quotient rule here again and see what kind of happens. T to the -5 is in the denominator. Here I have a 1. Recall that 1 is equivalent to anything raised to the 0 power. So I could actually put in a t to the 0 here, and we could apply our quotient rule. T to the 0 minus -5. Well, 0 minus -5 equals t to the 5th. Therefore, 1 over t to the -5 equals t to the 5th. Here we have x to the -9 minus 2. X to the -11th, 1 over x to the 11th. We have 5 times p to the fourth minus negative 3, which gives us 5p to the seventh. Last few, we have 2 to the negative 3 minus negative 1, which is 2 to the negative 2, 1 over 2 squared, 1 over 4. 2/10 x to the negative 7 minus 1, y to the second minus negative 5. 1/5 x to the negative 8th, y to the 7th. 1/5, 1 over x to the 8th, y to the 7th. So we're left with y to the 7th as our numerator, and x, and 5 over x, or 5 times x to the 8th as our denominator. Here we'll apply a mix of our rules. We can do our numerator first with our product rule. 3 times x to the negative 2 plus 2 over x to the 6th. That gives us 3 times x to the 0, which is just 1. And then we have x to the 0 minus 6, 3x to the negative 6, 3 over x to the 6th. Base of x, 3a plus 4. Since we don't know what a is, we can't simplify that any further, so that's our exponent. Same base, 3t minus 2 minus t minus 3. We can distribute and combine like terms, giving us x to the 2t plus